Hi there, and welcome to Math with Bill. My name is Bill, and in this video we're going to be looking at limit of some trig ratios. Now this is really a calculus video, but if you're in trigonometry and you're dealing with limits as well, so probably at a pre-calculus class, this can be a helpful video, and so hopefully it is. The two major ratios that we're going to look at in this video are the idea of sine of delta theta divided by delta theta as delta theta approaches 0, okay? And a limit as delta theta goes to 0 of cosine delta theta minus 1, all divided by delta theta. So these are the two that we're going to see a lot if we do limit definitions of the derivative for trig functions in calculus, and so that's why I thought this video would be appropriate and helpful. So the large thing that we want to think about here in this video and really with the limit of these ratios is the idea of the unit circle which hopefully isn't a mystery to you, but if it is, this is a circle with a radius of 1, okay? And so we want to think about the unit circle, and the other big thing is the way that we measure our angle today, and really in all of these derivatives and limits, it's going to be in radians, okay? I know that degrees are sometimes easier, but this is all going to be based off of the idea of radians, and there's 2 pi radians in that full unit circle, okay? So anytime we take the definition of an angle, it's some rotation from the initial side to the terminal side, and we call it theta. In a unit circle, the interesting thing is that the intercepted arc, or the arc of the circle, when it's a unit circle, is that same exact theta. The number of radians covered on the outside is the same as your angle, okay? And we're going to use this idea to help us explain these limits, okay? So, quick from right triangle trig. If we've got our right triangle here, here's theta, and so this would be our sine value with a hypotenuse of 1, and this would be our cosine value. We're going to use that in our next couple of drawings. Okay, so the first drawing here I'm going to represent is this arc. Okay, so I'm going to blow this thing up, and so I have my arc. Okay, there's theta. Okay, here's the center of the circle. Each of these 2 sides of the arc are a radius of 1. And what we need to do is look at the top of the arc, and if we draw a vertical section straight down, creating a 90-degree perpendicular intersection, then that dotted line that I just drew down is known as sine theta. Okay? And the horizontal line from the center to that perpendicular intersection is cosine theta. Okay? The 1 here pertains to the entire segment, and cosine is the difference there. Our arc is still theta, and the only piece that we don't have defined here is this little section. And this little section here is the whole 1 minus the other part, cosine of theta. Okay, and so that's really important to notice. Now, what we want to do is we want to explore what happens as we change this and it goes to 0. Okay? Because we know that both sine and cosine will go to 0, but how does it happen? So what I'm going to do here now is I'm going to blow this up, okay? I'm going to expand it, and I'm going to decrease to something more like this, okay? So here is the next drawing. notice that this is larger. Again, you can imagine this as okay, so it's a smaller angle here. We've took and zoomed in. It's like we're looking at it under a microscope, and so we've created this larger angle. Okay, and we still have our sine theta, our angle theta out here, our cosine theta, and our smaller section of 1 minus cosine theta, and our hypotenuse here of 1. Okay? And so what we're looking at here in this picture is what we want to do is we want to compare first sine of delta theta to theta. Let's compare sine to the arc length. Okay? And as we get smaller, or as we become closer and closer to 0 on this angle out here, what happens is that we have an approaching sine value. Okay? So as we get closer to a 0 degree, hopefully that you can see that the difference between the vertical line and the arc is becoming smaller. Okay? And what happens is that as sine theta goes closer and closer, okay, so as our angle is becoming smaller and smaller, the arc length and the sine length become the same, which means that this ratio becomes one thing to its exact counterpart, and that's the limit, which gives us a limit of 1, okay, because it becomes something divided by itself. Okay, and that happens at its tangent point, or where we're dividing by 0. Okay, so this ratio becomes 1. Now, let's look at our horizontal piece. Okay, and when we're comparing these two, look at the huge length of our arc as compared to the very, very small length of our 1 minus cosine. Okay, and as we get closer to 0, hopefully you are noticing that the bottom piece is rushing towards 0 much, much faster than the arc length. Okay, and so the top piece here, our numerator, is rushing to 0 faster than our arc length, or our denominator here. Okay? And so if this is going to 0 faster, our limit over here becomes 0. These are two really important things that you need to remember. Limit as delta theta goes to 0 of sine delta theta divided by delta theta is 1. And over here, cosine delta theta minus 1 divided by delta theta is equal to 0 when we're taking those limits. Okay? Hope that helps. Watch the rest of the trig videos, and good luck.